Hello and welcome to an introduction to the new IBM Z17 mainframe computer. This new machine is a serious piece of modern technology built for the digital world that we live in. It supports everything from transactional workloads and massive databases to AI and everything in between. This information is sourced from 3 IBM Red books: the IBM Z17 Technical Introduction, the IBM Z17 Technical Guide, and the IBM Z Connectivity Handbook. We at the European Mainframe Academy have tried to extract the essentials and present them clearly. We think it's important to unpack what makes this system so important and why we should care about this in 2025 and the upcoming years. The technical guides give us the blueprint of the new Z17, and the Connectivity Handbook explains how does the new machine talk to the world, what are the big performance jumps, and what role do they play in things like keeping our data safe, ensuring systems are always up and running, and now even in things like artificial intelligence. We don't want to get too bogged down in technical jargon, and we don't want to lose anyone in the weeds. So let's just start with the physical system itself. The Z17 can be configured with 1 to 4 frames, like the Z15 and Z16, and these are basically main equipment racks. Inside these frames, you can have up to 4 CPC drawers, and depending on the configuration, up to 12 I/O drawers. All this stuff and more control and cooling equipment fit in the standard 19-inch rack format introduced with the IBM Z14 ZR1. Modularity is a wise design choice. You can start with a single frame and expand up to 4 frames with up to 64 terabytes of main memory and up to 208 configurable processors. What's particularly interesting is the clear separation between the processing power in those CPC drawers and the I/O handling in the I/O drawers, which allows you to scale and upgrade them independently. So let's zoom in on those CEC doors a little bit. There is the Baseboard Management Controller, BMC, and the oscillator card, OSC, which can be seen as the machine's central nervous system. We also have the power supplies for the processors. Then we see these CBC drawers. The A frame can hold 3, and the B frame can hold 1. These drawers are the heart of the system because they hold the processor chips and the mainframe memory DIMMs. We talked about the drawers, but how does this machine actually communicate with the outside world? How does it talk to the network and the storage subsystems? Without going too deep into the internals, we have PCIe Gen 5 dual-port fanouts, and that means a pretty big leap in data transfer speeds. We are talking about 32 gigabits per second to those I/O drawers. As we can have up to 12 of these I/O drawers, we get a theoretical I/O rate of nearly 4 terabytes per second. This is a massive amount of bandwidth just for moving data in and out of the system, and a real unique characteristic of IBM mainframes, and is absolutely critical for handling the enormous volumes of data that modern enterprise applications generate and consume. So, how does all this raw speed translate into actual networking connections? How do we connect to the internet, to our internal networks, and so on? Well, the Z17 offers OSA-Express 7 cards in version 1.2. It supports something called Network Express, which is a pretty versatile adapter. It does high-speed networking with long-distance clustering with speeds up to 25 gigabit Ethernet traffic. Let's now take a look at connectivity to storage subsystems, of course also important in an enterprise environment with huge I/O traffic. The Z17 features FICON Express 32, which means 32 gigabits per second is supported, but the adapter can automatically adjust down to 16 or 8 gigabits per second to work with a wide range of storage systems. And then there is another thing called zHyperLink Express 2.0. This is specifically engineered for incredibly low latency connections to their DS8000 storage systems. CyberLink is where things get interesting, especially for applications that are sensitive to delays. Creating this straightforward, very low latency pathway to the DS8000 storage can dramatically improve response times for critical workloads, including forward error correction. It shows a commitment to data integrity, especially as those data transfer speeds increase. and the physical distances can be significant.